Welcome back, everybody. Today we're going to go on with our polygon explorations and we're going to be doing quadrilaterals. So if you remember on the first day that we started this lesson on Monday, this chapter, we were classifying the polygons, and if it had four sides, we were calling it a quadrilateral. So today we are going to learn how to further classify quadrilaterals. So we'll be able to decide what to actually call them, whether they're squares, rectangles, etc. Okay? Before we begin, I just wanted to remind everybody something that I haven't reminded you in a while, but if you are ever having a hard time with a lesson and you've watched my video and you've tried to follow along and it's still just not making sense, remember that you can go on the Interactive Student Edition. Okay? So if you forgot how to get there, remember that when you log into your Think Central account, it looks a little different than mine. Mine is the teacher one, but you look for this yellow Interactive Student Edition. Once you click on that, it brings you to this page and you look for the chapter that we're working on. So we're all the way at the bottom. We're in Geometry and Volume, and then you select the lesson that we're working on. Okay, so let's say you do today's lesson and you're just totally lost. You can click on here and it brings you to the whole lesson, and you know how this works. It can walk you through the entire thing. Okay, so I just wanted to remind everybody about that. Okay, so that being said, let's move on. Let's learn how to classify quadrilaterals. So for today's Unlock the Problem, we're looking at the seating chart for a baseball field. It's got many four-sided figures, or quadrilaterals. What types of quadrilaterals can you find in the seating chart? So there are 5 special types of quadrilaterals that we're going to deal with. So we can classify them in different ways, kind of like how we did it with triangles. When we did it with triangles, we looked at how many angles, the types of angles that they had in them, and we also looked at the number of sides that were congruent. So when we're classifying quadrilaterals, we're going to be classifying them by their properties. So some of the things that we're going to look at are parallel sides, perpendicular sides. So in order to be able to do that, we have to just really quickly talk about what that means. Parallel lines are lines that are always the same distance apart. They will never ever touch, right? So they look like train tracks, kind of, right? They'll never intersect. Perpendicular lines, on the other hand, intersect to form right angles. So if you have a perpendicular line, a line that is perpendicular to another line, it makes a right angle. So when we're talking about perpendicular lines that are in a quadrilateral, they are perpendicular when they meet at the corners, like this. Okay? So that's what we mean. And if they're parallel, it means that they're the same space apart and they're never going to intersect. So just to clarify before we begin. So we're going to start off by completing the sentence that describes each type of a quadrilateral. So for this one, a general quadrilateral has 4 sides and 4 angles. So when you just look at a shape or a polygon and you're saying, okay, what polygon is this? If it's got 4 sides and 4 angles, we can say, okay, it's a quadrilateral. To take it further, the first type we're going to talk about is a parallelogram. Okay, parallelograms, you're going to need to know for 6th grade as well. It's a special trapezoid that has opposite sides that are congruent and parallel. So, in order to classify a parallelogram, the opposite sides are congruent. So this side is opposite of this one and they're equal. This side is opposite of this one and they are equal. They're not all of them the same necessarily. This side and this side are equal, and they are also parallel. So we're going to write congruent and parallel. So they will never, ever, ever intersect. And that's how you classify a parallelogram. Okay? Now, I think maybe I should have started with the trapezoid. A trapezoid is a quadrilateral that has at least one pair of parallel sides. Okay, so it might have two pairs of parallel sides, but it has at least one pair. And you can see here that this side and this side are parallel. They're never gonna intersect. And sometimes the other pair of sides are not. So you can see this side, if it keeps going, it's going to eventually intersect with this one. So those two are not parallel. And then we talked about our parallelogram being a special trapezoid. So it does have at least one pair of parallel sides. Okay? Now, a rectangle is a special type of a parallelogram. This type of a parallelogram has right angles. Okay, so that's what makes a rectangle different than a parallelogram. So it still has opposite sides equal, right? And now the difference is that it has 4 right angles. Okay, so a rectangle is a special parallelogram with 4 right angles. And now, instead of saying parallel sides here, we are going to be specific. And if you think before what I told you, if you have 2 sides that are forming a right angle, that means that they're perpendicular. Okay? So it's parallelogram. The opposite sides are equal. But what makes this a rectangle is that it's got 4 right angles and all the sides, and it has perpendicular sides. Now we're dealing with what's called a rhombus. And a rhombus kind of looks almost like a diamond, just kind of moved a little bit to the side. So a rhombus is a special parallelogram. So you want to think of it like this. The difference between a parallelogram and a rhombus is that all 4 sides are equal. So it's a parallelogram because the opposite sides are congruent and they're parallel, but to make it even more specific, all 4 of the sides are congruent. And finally, a square is another special parallelogram. So it's got opposite sides equal and opposite sides parallel. But this time, all 4 sides are equal and all 4 angles are right angles. Okay, so a square is a special parallelogram that has 4 congruent sides and 4 right angles. So the difference between a rectangle and a rectangle has all those 4 right angles, but all 4 sides are not equal. Opposite sides are equal. A square has all 4 angles as right angles, and also all 4 sides are equal. So the quadrilateral classification can be a little trickier than what we've been doing so far, but don't get yourself overwhelmed. You can always refer back to this chart to help you out. Okay? Going back to that unlock the problem, if you can see some types of quadrilaterals that you can see, there's basically everything here. There's trapezoids, there's parallelograms, rectangles, rhombuses, and squares. So this is one of the more confusing type things within geometry, where you have shapes or quadrilaterals that are sometimes a certain type of a quadrilateral and other times are not. So we're going to just practice looking at this because you kind of do need to know it. Now you can actually draw this and cut it out, cut out the quadrilaterals and place them in the Venn diagram. And you don't have to do that, but if you'd like to do that, you can. I'm going to just complete the sentences. So the first one is that a rhombus is blank a square. So is it always a square? Is it sometimes a square or never a square? So here's my rhombus circle. So a rhombus is the trapezoid is the biggest, right? Actually, I'm sorry, the quadrilaterals are the biggest. Within the quadrilaterals, we have trapezoids, which just means at least one of the sides, pairs of sides, is parallel. Then you have parallelograms, which are always trapezoids, but parallelograms have both opposite sides parallel and opposite sides equal. Then it breaks up either to rhombuses or rectangles. So the rhombuses have all the sides equal, and the rectangles don't have the sides equal, but they have 4 equal right angles. Then finally, a square is considered both a rhombus and a rectangle because it has all 4 sides equal, which is a rhombus, and it also has all 4 right angles, which makes it a rectangle. It's kind of confusing, but when you look at it this way, I think it helps. So is a rhombus always a square, or sometimes, or never? So as you can see, a rhombus is a rhombus, and sometimes it's a square, right? Because a rhombus doesn't have to have right angles, but it could. A parallelogram is blank a rectangle. Is a parallelogram a rectangle sometimes, always, or never? So parallelogram, again, it doesn't have to be a rectangle, but sometimes it might be. So a parallelogram can have the opposite sides equal, but it doesn't have to have those right angles, but sometimes it does. So that's another one that's sometimes, right? A rhombus is sometimes, always, or never a parallelogram. So a rhombus is inside the parallelogram circle. So it's always a parallelogram, right? And remember, a parallelogram is opposite sides are equal and parallel. So a rhombus always has opposite sides equal and parallel. So it's a parallelogram. A trapezoid is blank a parallelogram, and that's going to be sometimes, right? Trapezoids encompass almost everything else. So a trapezoid is sometimes a parallelogram because it doesn't always have to have opposite sides equal, and it doesn't have to have both opposite sides parallel, only one. Sorry. A parallelogram is blank a trapezoid. That's going to be always because it's inside that circle. Parallelogram is always a trapezoid because it always has at least one opposite pair of sides parallel. And then finally, a square is it sometimes a rhombus, always a rhombus, or never? So it's within the rhombus circle and the rectangle circle at the same time. So it's always a rhombus because a square always has opposite sides equal. I know this is confusing, so try not to let yourself get overwhelmed by this. You can always refer back to looking at the diagram if you need to. So, yeah, we're not going to do these 2 questions. I just want you to practice classifying. So, for your share and show, we're looking at this quadrilateral ABCD to answer the question. We're supposed to be measuring the sides, and I don't know how many of you actually have what you need, so I'm just going to tell you. Measuring the sides, are any of the sides congruent, and then we're going to mark them. So if you measure this, what you're going to see is this side and this side are equal, so they are congruent. We're going to put 1 dash. I should also write yes here, okay? And then when you measure AB and DC, they're also equal, but they're different than these, so we're going to do 2 dashes like that, okay? How many right angles, if any, does this quadrilateral have? We can see that there are none, okay? It would either have been indicated with that little box, or we'd be able to tell that it's an L shape. There's clearly none here. How many pairs of parallel sides, if any, does the quadrilateral have? Looking closely, we can see that AD and BC are parallel. They're never going to intersect. And AB and DC are also parallel. So it has 2 pairs of parallel sides. So we're going to decide what 2 things we can classify this quadrilateral as, okay? So first and foremost, we go from the most broad one that we can. The most broad classification is the trapezoid. So this is a trapezoid because it has at least one pair of parallel sides. So it counts as a trapezoid, and now we're going to go further down and see what else this counts as. So if you're looking at your classifications, opposite sides being congruent makes this a parallelogram as well. So this is also a parallelogram. Okay? Now, when you classify on your own, you don't have to write both. You're just going to write the one that is the most specific. So if I were to classify this on the homework, I wouldn't have written trapezoid and parallelogram. I would just say it's a parallelogram. So we're going to try these two. Instead of giving you guys a chance to do it on your own, I'm just going to do them so that you can see, because I know this is a little bit tricky. So they are saying to classify it in as many ways as possible, but I'm going to do the most specific way, okay? So I'm going to start off with the trapezoid, right? At least one pair of sides is parallel, right? So this is definitely a trapezoid. Going further, does it count as a parallelogram? Opposite sides are equal and the sides are parallel. So it's definitely a parallelogram. Let's go further. Does it count as a rectangle? Opposite sides are equal and it has 4 right angles, okay? So this does count as a rectangle. That would be the furthest I can go. It's not a rhombus, right? Because it doesn't have all 4 sides equal. And it's not a square because it doesn't have all 4 sides equal. So the furthest I can go here is it's a rectangle. And if I was going to list all the other ways, it would be a quadrilateral. I'm going to abbreviate. It would be a trapezoid. It would be a parallelogram as well. But the final stop would be rectangle. Number 3. Okay, number 3 I'm glad was included because this is what a trapezoid looks like. Okay, a trapezoid that's not classified any further. So all it's got, of course, it's got the 4 sides. So technically, we can say that this is a quadrilateral, of course. But now, it has at least one pair of parallel sides. That was really messy, sorry. It's only got one pair of parallel sides. So that makes it a trapezoid. I can't go any further because opposite sides have to be equal in order for it to be a parallelogram. So as you can see, these sides are equal, but these are not. So it can't be a parallelogram. And the other pair of sides are not parallel either. So it cannot be a parallelogram. Sorry. Okay, so that makes it a trapezoid. So again, on the homework, I think you're asked, let me just make sure real quick, I'm going to look. It does say as many ways as possible. So you can list as many ways as you like, but I'm also perfectly fine with you arriving at the last one because technically if you tell me that this is a rectangle, that means that it's also a parallelogram. It's also a trapezoid and also a quadrilateral all at the same time. Okay, so if you choose to just do one, that's fine. Okay, I'll let you pick for the homework. All right, guys, have fun with this. I know it's a little bit trickier than the others. Just keep your Venn diagram or your chart handy to help you classify. Okay, have fun.